Well, I would like to thank Naresh sir and AIOC for giving me this opportunity. So I'll be talking on principles and benefits of 3D operating system. I have no financial interest. So we all know the evolution of man. I'll just in brief talk about the evolution of ophthalmic microscope. The first magnifying technique used was a spectacle frame with single plus lens towards the end of the nose. Then came the head-worn microscopes, then the uniocular microscopes, then the current generation binocular microscopes, and then finally the heads of surgery. So the currently available 3D vision system include the Ingenuity provided by Alcon, the RTO800 provided by the Carl Zeiss, and the Leica microsystems, which are currently withdrawn from the market. So what is the problem with analog microscope? Analog microscope forces the surgeons to assume an awkward posture. Awkward posture for long durations will lead to a microskeletal disorders. Around 58% of people have reported productivity loss due to musculoskeletal disorders. In another survey, around 48% of surgeons experience occupational musculoskeletal pain, which are directly attributed to the OR. On a long OT day, surgeon puts a lot of stress on his neck as well on his back, resulting in chronic back pain, neck pain, shoulder pain. So the time has come when they develop equipment better suited for the surgeons. So let's meet the 3D system. So the eyepiece has been replaced with a 3D high dynamic range camera. This provides the images to the high-speed image processor, which will ultimately project the video on an OLED surgical display. So let's meet all the components now. The first is there are two 1080 pixel 3D high dynamic range CMOS camera, which provides 60 frames per second per eye. So what is a high dynamic range camera? A dynamic range is the ratio between the minimum and the maximum light intensities in an image. So low dynamic range camera can differentiate only within a small range of brightness. Outside that range, features are not visible. So brighter area will appear pure white, while darker area will appear pure black. So this is an example of high range camera, which can image from black to white, while low dynamic range camera will only image from gray to gray. So the ultra high dynamic range sensors allow the surgeons to operate with less illumination. So what is a CMOS camera? CMOS camera, a high dynamic range camera, will need to take multiple recordings, then process them, and then produce a high dynamic range image. On the contrary, CMOS camera will produce high dynamic range from a single recording. So that is why it can produce live image for surgery. So the second is the ultra high speed image processor. It processes simultaneously streams 3D and 2D images and provides real-time 3D videos. The third component is a OLED surgical display. It is a medical grade 55-inch organic LED with a resolution of 3840 into 2160 pixels. It allows surgeon to use high acuity photopic vision to view spatial details and provide crisp view with natural colors. And the last is a 3D goggles. We all know how 3D works. Brain uses the binocular disparity to perceive depth. So what are the benefits? First one is the improved ergonomics for the surgeon. Surgeon can relax his or her body while operating. Believe me, more than the surgeon, the residents love it. The scrub nurses get more engaged. They're able to anticipate next step and the required instruments. The learning as well as the efficacy of the whole OT improves. It's easy to guide young surgeons when they operate. It is not now necessary to stand on the head of the patient and speak to your surgeon whom you are teaching. You can sit a few meters away and just guide him with the help of a Bluetooth. It is easy to switch seats. Now it is not necessary to adjust the IPD and height of the binoculars regularly. So it provides high magnification without affecting the details. It provides high resolution at high magnifications. As we can see, even the smallest area can be magnified and there is no loss of resolution. So this screen will provide better clarity. This is a standard definition screen. This is a high enhanced definition screen. This is a high definition screen, while this is the OLED screen with high pixel quality. It provides an extended depth of field. All the anatomical structures and the instruments within the large vitreous cavity will remain in sharp focus while performing the various steps of the surgery, so you do not miss on anything. There's an enhanced depth of field. For example, in this photo, you can see the mountain range in the front are very sharply focused, but the mountain range that are behind are not sharply focused. Whereas this is not the case with 3D visualization system. All everything is at sharp focus, and you can see each and every part of the retina while performing surgeries. So in analog microscope, at higher magnification, there's a loss of field, especially in the periphery. But in case of a 3D visualization system, there's no loss of peripheral field, even at high magnifications. 3D visualization system reduces the illumination level by 50%. So that means less illumination, lower phototoxicity. So there are a number of filters that are available, which we can use. Blue filter can be used to cut vitreous. Green filter can be used to do ELM peeling, and red free for IRM peeling. Now we can integrate the complete OR. With the help of the data fusion software, we can integrate our phaco machine, our vitrectomy machine with the screen. So now the surgeon can track the key data parameters such as IOP, flow rates, cut rates, infusion pressure, and laser power on the single screen. So it has been integrated with anterior segment as well as posterior segment surgeries. So we can do corneal surgeries, glaucoma surgeries, and VR surgeries with the help of intraop OCT. Even hybrid varieties are available. Here the surgeon can view from the binoculars and rest can have a 3D view. It can even be connected to the cloud. So you can connect to the IOL master while you are sitting in the OT, and while you are sitting at the home, you can access data from the IOL, from the machine. So we saw the utilization of DAVS for high volume vitreoretinal surgery. We found that it is easy to adapt. Also, it has a good quality recording and an inbuilt software. This is a surgery which is being done. The DMS is being used to scrape the vitreous. So we can very high definition, we can see the vitreous as well as the retina. It has a large storage area. More than 100 hours of 3D video are available on its internal hard drive. There are a few disadvantages at present. It is a space occupying device. It is costly, but as we know, the cost will definitely come down, and there's a time lag. So there's a bit difficulty in anterior segment surgery. Thank you.